SRI was founded in 1946 in the heart of what's now known as Silicon Valley. And since the very beginning, we've created and delivered groundbreaking innovations to protect our planet and promote a healthier, more sustainable world for future generations. SRI researchers have helped reduce smog and pollution in some of America's biggest cities, developed sensors that give us critical information on weather patterns, air quality, and ocean health, advanced technologies that convert solar and the power of water to renewable energy, conducted pioneering work in carbon capture and storage, and developed smart grid technologies and energy-efficient materials. We're developing innovations that can help our communities prepare for and respond to extreme weather, be more resilient, and adapt to the impacts of climate change. Our customers and collaborators in government, industry, venture capital, and academia trust us to work alongside them and apply our expertise to climate challenges. Because protecting our planet is not just our legacy, it's our future.
Hello and good afternoon, and thank you very much for coming. Welcome to PARC Forum. It's nice to see people who have joined us in the past, and quite a number of you are here for your first PARC Forum, and quite a number of people here whose familiar faces. So thank you all for coming, and thank you to those of you who are online watching as well. PARC Forum, for background, was first established in 1977 as PARC's invited speaker series for public engagement. We've had the pleasure of relaunching PARC Forum earlier this year as a way to bring together some of the world's most interesting people working at the intersection of technology, society, and business. If you enjoy this event, please go to sri.com/events and sign up for our mailing list. We have future events coming up next year on biosciences, the future of technology, the future of education and work, and many other topics of interest. A few housekeeping notes. If there is, in the very unlikely event of a natural disaster, please just go out the way that you came in. This event is being live streamed, and I would just note, I learned this last week, the very first internet live stream took place 31 years ago this summer, right up at the patio, where we're going to be having our reception. So you can enjoy that piece of history while you're there, and we do hope you will join us upstairs after the event. I want to let you know that we lock the doors after the event, so please take your belongings with you after the event is over. We'll take questions from our audience on these note cards. You either received one or can receive one if you raise your hand. We'll bring them by. Write your questions on the little golf pencils that we have. If you want to hold on to your card, or if you find it interesting, these all represent different innovations from SRI over the last almost 80 years. So interesting facts about technology and Silicon Valley technology history. So please take one, take two, take a few if you'd like some. So we will take questions that way. Again, welcome to PARC Forum. I'm very pleased now to introduce our CEO, David Parek, for introductory remarks. David?
Hello, everyone. Just wanted to add my welcome as well. And in a bit of history, it's a nice symmetry because even before PARC Forum, SRI was founded in 1946, spun out as an independent nonprofit in 1970. It was founded as part of Stanford Research Institute. The Sarnoff Labs added in the 80s, and just last year, delighted to have the Palo Alto Research Center, PARC, be part, and that's in fact where we are. But SRI had a forum series as well. And one of the speakers came and spoke about electronics in the West. And it was none other than David Packard. So I thought very fitting. Tonight, we have Julie Packard coming to speak with us about oceans. I think many of you probably know SRI for its work in computer science, companies spun out like Siri, Nuance, Intuitive Surgical. You may not realize how much work actually has gone on here related to the environment, not only smog in LA, but some real seminal work with regard to the ozone layer and things in that space. And currently, a lot of work related to the carbon cycle, things for carbon capture, sequestration, and things in that realm, as well as thinking about the future of energy. Delighted also to welcome a good friend of mine and representing the Doerr School of Sustainability, the Dean, Arun Majumdar. And we are delighted that they could work with us in terms of co-hosting the event, and our colleagues from KQED who are participating with us as well. I would like to introduce our keynote speaker, Julie Packard. Julie is a marine biologist and founding executive of the Monterey Bay Aquarium. Her work and that of her team very much involved in studying and mitigating some of the biggest issues that we face with regard to our oceans, from sustainable seafood to climate change and many other topics that you'll hear about tonight. She's recognized as a global force for ocean conservation, creating and sharing science-based education programs and innovative exhibitions. And when we had been talking before, we thought what a wonderful way to motivate and catalyze another generation, even the current generation of scientists and technologists working in other spaces, thinking about how they can bring their innovation to this as well. She's a fellow of the American Academy of Arts and Science, and she chairs the board of the Monterey Bay Aquarium Research Institute, vice chair of the David and Lucille Packard Foundation Board, and she's received the Audubon Medal for conservation. Please join me in welcoming Julie Packard.
Thank you, David. It's great to be here, and I have a little story to tell about the connection between SRI and the Monterey Bay Aquarium, which is that SRI did the very first market feasibility study for the aquarium when we were first thinking about building an aquarium on Monterey Bay. I was telling David the numbers were all completely wrong, and but happily the whole math ended up in the black, and my father decided, that the family would go ahead with the project. So it's really remarkable, all the incredible work that SRI has done. I think you've probably spun off your market research piece, which is probably just fine. Well, so I am here to set the stage for our conversation, and want to start with just laying the context, setting the stage. So I'm here on behalf of the Monterey Bay Aquarium, but I wear many hats. But let's focus on our amazing Central Coast and kind of how all the science and research and innovation developed here in our part of the world. So here you're looking at Monterey Bay, and of course, as many of you know, not so long ago, probably 15 years ago, we would never have a map of the bottom of the ocean like we see here. I mean, that's been an incredible development. And in Monterey Bay, as you probably are aware, we have this amazing deep submarine canyon, and this Pacific coast that we have here has an incredible, what's called an upwelling system that just makes for extremely rich and diverse biota. I mean, it's a very rich system. And that really is what inspired us while we were teaching and doing research and being students around Monterey Bay to create a place where people could fall in love with the ocean and hopefully want to learn more about it, and hopefully ultimately do more to get engaged in protecting it for the future. And of course, our piece of ocean here is linked to the global ocean, the Pacific. And it's sort of often said and probably trite, but let's remind ourselves we do live on an ocean planet. I mean, the ocean doesn't only can cover about 71% of the surface, but in terms of volume, it's more like 97% of the space where life can exist on planet Earth. There is so much life in the ocean and so little that we know about it. And as we think about the challenges for the future in terms of making sure that the planet, stays a livable habitat for us and all life, the ocean is something that really needs our attention. So that will be my message here today. And I know whatever you're involved with, I'm sure that you have something to contribute to that mission. Well, so I was asked to make some introductory remarks about what's happening in the ocean and how humans are changing it, and what are the things that we need to address that are happening right now. And the way that I and a lot of scientists think about it is sort of in these categories. First of all, the most ancient human relationship with the sea, which is fishing. extracting food out of the ocean. That used to happen at a sustainable rate, but these days, with so many of us on the planet and the way that we're fishing, it is not sustainable, and the majority of our fisheries are overfished or fished at capacity. And then, of course, aquaculture, wild-caught fishing sort of stalled out in the 80s. That was a long time ago. Aquaculture is growing exponentially. It's a really important food source, a really important business opportunity, a source of livelihood, and of course, source of food security for something like 1 billion people on the planet. So it's a really interesting opportunity for improvement and innovation. So the second category, of course, is what we're putting into the ocean. And we've been hearing a lot about plastic of late, not only plastic trash, plastic in the ocean, plastic in our drinking water, human health impacts of plastic. That's one area. There are certainly many others, including all the nutrient and other pollution going on based from our land-based activities. And then, of course, climate change and its impacts. And I'll say a little about that. We all are seeing front and center the impact of climate change on land and our warming planet and changing climate. The ocean impacts are vast, and there's a lot of opportunity to understand more about them. And I would add actually a fourth category on here that kind of captures all of these, which is habitat protection. And you may have heard about the 30 by 30 goals, which are to protect 30% of the land and water on the planet by 2030. It's a really ambitious goal, but certainly the amount of land conversion and alteration that's happened in all of our coast is having a big impact on ocean health. Well, so the ocean and all of the global discussions about the environment and how to maintain a healthy environment, until pretty recently, it wasn't really on the screen. It wasn't really part of the discussion. And then a few years ago, all of us working on ocean issues were thrilled to see that there is now a Sustainable Development Goal number 14 called Life Underwater, which has this goal: conserve and sustainably use the ocean, seas, and marine resources. And when I look at all these goals from an ocean perspective, really, practically every one of these, achievement of practically every one of these depends on a healthy, thriving ocean ecosystem to do its job in modulating the climate and doing all the ecosystem services that it provides for us. So all of these things are absolutely linked to that goal of a healthy ocean. Well, so that's kind of setting the stage on, the problems. So how do we think about, or how do I think about, how does our team at the aquarium think about what we should do about it? And I like to think about it sort of from the standpoint of 4 different strategies, and no one is more important than the other, but the thing to remember about the ocean is that no one owns it. Land conservation oftentimes ends in, oh, you're buying it, you're making a protected area, so no one will mess with it. No one owns the ocean, so these ultimately, all of the innovations and solutions, they need to finally result in a policy action and some governance. That's kind of the end game. Before that, though, obviously, you want to build an audience that wants to get engaged, and that's what we do at the aquarium. You need science, and there's just a huge opportunity, huge unmet need for science and engineering and technology development. I'll talk more about that. But one also that is extremely important, and one that we've focused on a lot in our work at the aquarium, is the influence of markets. Seafood is a globally traded commodity. The US is a huge market, probably the number 3 market for imported seafood that is globally traded. Most of us don't think of it that way, but that is the truth. And from that idea, we launched our Seafood Watch program, which I'll talk a little bit about, and the importance of working with the business side to work on more sustainable and marketable ways to use the ocean is a super important part of the solution. Well, so fishing, we've all read about industrial scale fishing. I don't need to say much about it. The way we are fishing and the scale at which we're fishing has led to depletion of what once was a very abundant ocean. And so we're not only losing the fish, we're affecting the ecosystems, and a lot of the way we're fishing is causing severe habitat damage on the seafloor that's not going to recover for a very long time. And of course, there are also a lot of human rights issues associated with the seafood industry. Maybe some of you have read articles about this. And all around, it's an area needing improvement. And then aquaculture, which I said is growing exponentially. And it is a real opportunity, and we can do aquaculture right. Right now, it's not always done right. It can cause a lot of water pollution issues. There's heavy use of antibiotics and things like salmon farming. So this is really more an opportunity to learn how to do it in a way that works on the business side, but also is more benign for the environment. So Seafood Watch, hopefully many of you have heard about the Seafood Watch program. You maybe had a little pocket guide or used our app. It's actually a mobile site now. You can look up anything you want to know. There's something like 3,000 fisheries that are evaluated against sustainability criteria. What has happened as a result of building that consumer awareness has been really establishment of a whole movement, a whole demand, and a lot of media attention, actually, most importantly, to get all the retailers to move toward wanting to get off the unsustainable Seafood Watch red list and into the good for the environment, good for the fishery green list. And this has had a huge impact. I've been really astounded and really proud of the team. Something like 85% of the big retailers in the US now have made commitments to only serve sustainable seafood on a time-bound basis, which is quite remarkable. And so now it's, where are you going to get that sustainable seafood? So it's now on to moving with the big seafood producers around the globe. And here in the US, the big seafood items that we love are all imported. Shrimp, number one, it's all imported, all grown in aquaculture, and vast majority not in a very sustainable way. Salmon, the vast majority of which is farmed. Again, big need for improvement, heavy antibiotic use in the salmon farming industry. That's something our team is working with those businesses. Most of it comes from Chile, where we are, and progress needs to be made. And then, yeah, those are the two big ones. And then, of course, a lot of policy action has come out of all of this work and the raising awareness of it, including bringing attention to all of the unreported and illegal fishing that goes on. There's treaty measure now that's in place to prevent landings around the world. So good progress, but so much more to do. One of the things, again, this doesn't illustrate it well, but one of the things that our team is doing that's an opportunity for innovation is to get tools in the hands of the small farmers who are doing aquaculture around the world to test their water quality in a low-cost way, that they can move toward a Seafood Watch green. And in fact, 10,000 plus shrimp farmers in Vietnam have made a commitment to do that, and we're working with them on what they need to do to make that happen. It's really exciting. Well, so the next thing that was in the big threats we need to do something about, plastics. We've been reading a lot about it. Plastic hangs around for something like 400 years in the environment, not good. Plastic is not very recyclable. The vast majority that we think we've been recycling over the past few decades has not been recycled. There's a lot of innovation going on in this area, but a lot more is needed. One of the things that has really caused a lot of momentum of late is a National Academy study. Actually, our Chief Conservation Officer, Margaret Spring, chaired this, and it identified and brought to light the fact that the US, we actually are a big part of the problem. We usually would think that countries, maybe cities on the coast of Asia or places that are big giant cities right on the coast, or maybe that don't have waste management, they're causing the problem. We are a big part of the problem. And the US actually for the first time has a policy about this. And then in California, we've passed this really progressive law to reduce plastic waste. It's really aimed toward extended producer responsibility, a circular economy concept. So it'll be a challenge to implement, but very exciting that at a local level, we're seeing these changes. Well, so certainly the mother of all issues, threatening ocean health, is global climate change. And the ocean is, as we see here, the heart of Earth's climate system. All of the severe weather that we've been seeing, of course, we all know it's because circulation patterns and heat in the ocean driving climate in very severe and unpredictable ways we haven't seen ever, at least not during our course of human history. And the idea of mitigating climate change and slowing greenhouse gas emissions, sequestering carbon with sustainable methods as needed, and really whatever we can possibly do to slow down the march of climate change impacts on the ocean and all of us is imperative. I mentioned most people don't really haven't had exposure to what these changes in Earth's atmosphere mean for the ocean, and this is a graphic that just lays it out very simply. You can take it in yourself, but all of these things, the ocean warming, the less oxygen in the water as mixing changes and as it warms up, and then the fact that the water is becoming more acidic as CO2 is absorbed into the ocean water, that's causing severe issues already on the base of the food web, or actually animals at all levels, any animal that requires calcium to make its shell structure, or and then all the metabolic and basic physiological impacts that all these changes have are just scratching the surface. We really don't have any idea yet about any of that. Well, so those are the problems. I'm going to close briefly with just a few things that I think are great signs of progress, that are kind of hopeful stories, and maybe get you thinking about how science and technology and engineering can move us forward in solutions on turning things around. So first of all, these amazing images of deep sea life off the coast of Monterey would not have been anything humans would have seen probably even 10 years ago with this acuity. So just beginning with the fact that technology is enabling us to see what is in the ocean and to really understand what's there as we think about seabed mining or other perturbations is, I think, really building a whole new awareness of, yes, there is a whole other planet on the planet that is worth protecting. So I mentioned MBARI, Monterey Bay Aquarium Research Institute, our sister institution, our partner in research and technology. To take that idea a little further, this thing you see in the middle is a living animal. It's a jellyfish relative called a siphonophore. It's a colonial jelly relative. And actually, you can think about this as one of the most abundant predators on the planet. It's an animal you've never seen, but the ocean is teeming with it and has a huge role in the food web and how carbon fluxes through the ocean and with the entire ocean ecosystem. So again, those images are really only possible because of technology to get down there and to do so with power and with a high level of video capability and also data gathering. You see on the left there, well, you see on the right, some of the more recent technology to get down there developed by MBARI. That's an autonomous underwater vehicle being deployed. These can go around and take measurements on their own, send them back to the lab from afar, and come back home And so there's incredible capability to learn more about the changes and be able to deepen our understanding of the changes going on. And then on the left there, you can see just a depiction of MBARI of a really kind of the direction things are going, where it's about developing multiple technologies to get a picture in 3 dimensions and through collaboration among many institutions. So the next thing that's kind of top of my list about super cool technology innovations helping us understand the ocean and protect and restore species is the development of satellite tagging of ocean animals. This is a giant Pacific bluefin tuna getting fitted with a satellite, what's called a pop-up satellite tag. It'll log where the tuna goes, and it will pop up to the surface, send its data to the satellite, and you can tell where it's been. This is a map of a big project called Tagging of Pacific Pelagics or Pacific Predators. Well, they changed the name of it. I forget which it is. Predators, maybe. Where you can see the information that can be had now from satellite tagging of all these animals, and you can start to identify the hot spots in the ocean, the places you might want to make a protected area because, say, it's a really important rich feeding ground, and also places where there might be issues with shipping lanes, say when the turtles migrate, et cetera. So very powerful tool we're going to see more of. Well, then, of course, this one is perhaps low tech, but where the aquarium works, which is just to expose people to the ocean. We've had 70 million visitors, I think, visits to the aquarium rather, since opening, which will celebrate our 40th anniversary on Sunday. Hard to imagine, and that's really where it starts. And so many people don't live near the ocean, they can't get near the ocean. All of these people now are getting linked in through all of the imagery in our social media and all the ways we can share all the cool stuff going on. That's a result of technology and innovation in the ocean. And then finally, of course, perhaps most important of all is education. And I know many of you are involved with educational institutions, and at the aquarium, we're working really hard on starting early, getting kids involved in doing science and inquiry-based science, doing research projects out in the field. And the ocean is really a place that you can get very excited and very curious, many things to be learned. I will end with, I always have to end with a cute sea otter shot because I'm the person from the aquarium, and just say that, the power of animals and animal empathy is, it's in the psychology domain, but it is extremely powerful. And what we are still learning at the aquarium, what motivates people, what gets them feeling hopeful, what gets them feeling just amazed and awed and full of wonder about the planet that we live on. And it's a huge privilege to be able to do that and work on things like making sure that these incredible animals are around for the future. So with that, I'll close. I guess just a final word, we are all clearly extremely privileged to live here in this area, to have access to data and amazing imagery and a beautiful aquarium, to move forward on behalf of nature and everyone on the planet. We need to do everything we can to be inclusive and make sure that everyone has access to education and to the tools that they need, the tools and opportunities to make for the vision that we have at the aquarium, which is envisioning a future where the ocean flourishes and people thrive in a just and equitable world. Thank you for the opportunity to set the stage here, and I look forward to the conversation. Thank you.
Thank you so much, Julie. I think you're going to be delighted with the panel session we have next. Joining Julie at the stage, I'd like to invite Rosa Tuirán to come on up. Rosa is video producer for KQED Deep Look series. She's a nature journalist and science communicator. She has a passion for making complex scientific topics accessible to the public, do it through a focus on storytelling, and his work has highlighted critical issues affecting our oceans and ecosystems. And she collaborates with scientists and environmental advocates to promote impactful content that helps us understand these important topics. So I'm going to turn over to Rosa to introduce the rest of our panelists and to moderate this amazing session that follows next.
So now I would like to introduce our other two panelists, Fiorenza Micheli. Fio is a renowned marine ecologist with a deep understanding of ocean ecosystems and interactions with humans. She is chair of the Ocean Department at Stanford Doerr School of Sustainability, co-director of Stanford Center for Ocean Solutions, and a marine ecologist at the University Hopkins Marine Station, and the David and Lucille Packard Professor of Marine Science. Her work has shed light on the effects of climate change, marine species, communities, and fisheries, including ocean acidification and hypoxia. Her research incorporates social ecological systems, combining ecological knowledge with economic and social factors to inform policy decisions. She's a leading voice in international ocean conservation efforts, advising governments and organizations on sustainable ocean management. Her passion is to inspire students and researchers to pursue careers in ocean science and contribute to a sustainable future. Welcome, Fio. I would also like to introduce Julie Bert. Julie Bert heads SRI's Hardware and Technology Research Lab here in Palo Alto, spending 11 years at PARC before it became part of SRI last year. She has a deep background in developing breakthrough research and technology. She is a senior leader at SRI and has overseen and contributed to numerous high-impact projects, demonstrating her leadership and vision in climate materials and other scientific areas. Julie is known for fostering collaboration across multidisciplinary teams, facilitating breakthroughs and bringing technologies out of the lab and into the world where they can have an impact. So welcome, Julie. So I would like to start kind of like to maybe a question to warm up a little bit. More of a personal experience, a memory. What inspired your, passion for ocean and science, or that kind of first sense of wonder? So, Julie, start with you.
Sure. When I was an undergraduate, I was a physics student taking undergraduate freshman level physics course. And one of the research assistants actually invited me to be an intern in the lab that he was working in for the summer. And this was my first time really getting to be hands-on with a large experiment. This happened to be a neutrino experiment where we got to go into an underground laboratory to shield neutrinos from other types of particles. You have to go deep underground, and we were building a giant detector with multiple scientists all contributing. And so it was really my first sense of getting to do hands-on work and discover questions about the universe that people didn't know the answers to yet. In your science classes, kind of up to that point, there was always an answer. And so it was very exciting to do that and to really have that experience. And I remember that as a really wonderful internship opportunity, and hope that we can still inspire students with those types of opportunities moving forward.
Thank you. Fio?
Thank you, and good evening, everyone. As for many, it's a very personal connection that you develop early on. As a kid, I grew up in Italy. I'm Italian, and as a family, we go to this island that is just off the coast of Italy that is called Elba. It's shaped like a fish. And that sense of connection started there, snorkeling on seagrass beds and exploring sea caves and seeing all the colors and the organisms. And then studying now up close the tide pools, the tiny creatures that you were mentioning, and seeing these small worlds with all these actions, all this behavior. And then if you spend time by the ocean or in the oceans as a surfer or a diver, or in my case as a researcher, you find that connection over and over and over in the field when you're underwater or on a boat. Sometimes it's hard, you're cold, you're beaten by waves, you have lots of setback. And then there are these perfect moments of peace and beauty that are very much of a metaphor, I think, for life. And perhaps best of all, that moment of discovery, that electrical jolt that goes to you when you make a connection. And for example, I know as an undergrad, I had a fellowship and I spent some time in Australia and dove on the Great Barrier Reef and was blown away by the fishes, the wonder that is this incredible natural monument. And then I went back to Italy and I dove again in Italy and went over urchin after urchin after urchin, beds of sea urchins and nothing else. And all of a sudden I made that connection that the fishes were missing and that perhaps the domino effect that goes through the food web when there's overfishing was the root of that. And Knockland conducted research on trophic cascades and this kind of phenomena. So I think that connection and the discovery are very close together, and it's one of the gifts I think that ocean gives us.
Thank you. Julie?
I am always asked this question, of course, being an aquarium director. And I actually didn't spend much time at the ocean as a child. We always went to the mountains. But I first got interested in the ocean as an undergraduate, and I took a class that was about tide pool biology. And I was very keen on studying botany, so I was with the plant part of the group. And we'd get up at ungodly o'clock, to go out for low tide in the freezing cold. But it was so peaceful. And as the tide went out and the tide pools were revealed, just this incredible cacophony of life. And these plants just totally fascinated me. These seaweeds, how could they live there with waves crashing on them? And you look at the kelp forests off our shore. I mean, they had this incredible set of adaptations, and they were just, survivor plants, I guess, and in any case, like Julie, I had been offered a paid internship early on as an undergrad, which was amazing. I was so excited. And I remember my dad was mad at me because he wanted me to go to have a summer job at HP. He was not happy at all. And anyway, so my job was identifying all the marine algae. There were hundreds of species in Monterey Bay, and they were just beautiful and so supremely adapted. And even now, when I look at the kelp forest exhibit in the aquarium, I mean, they're gorgeous. And the aquarium logo, of course, is a piece of giant kelp. So I guess I was smitten early on with kelp, which I know is pretty unusual, but I invite you to join me with a seaweed obsession.
I have to say kelp is really cool. I've, lately been like really in love with kelp. And so, Julie, you set the stage and start talking about what are some of the challenges, that our ocean faces right now. And I think I would like to ask this question to both you, Fio, and Julie. Which challenges, do you think require maybe our most immediate attention? Because there are many, as we heard. But Fio, maybe I'll start with you.
Yeah, I think Julie presented the main four: climate change. One of the scariest graphs I've seen is the global average sea surface temperature from NOAA. Year after year, you see the trends, the seasonality, and then you can see that for over a year now, every single day, it's record temperature. We have broken a record every single day. The extent and degree of warming with much variability and heterogeneity, but overall globally is require immediate attention, as is ocean acidification and many of the other stressors that Julie. Fisheries overexploitation, it's not only affecting stocks, but also entire ecosystems and livelihood. Fishes are a very important source of food and nutrition. It's not just an economic impact when fisheries collapse, for hundreds of millions of people around the world. So the reason why these are crises is because they're biodiversity crisis, they're human crisis of food, conflict, equity. And so there's these ramifications and the urgency, and then habitat destruction, pollution, and particularly for habitats that are also part of the solution to climate change. For example, blue carbon habitat, coastal habitats that protect shorelines, that sequester carbon, and also pelagic habitats. For example, there was this incredibly interesting study that just came out with an estimation of carbon sequestration potential from krill, the tiny crustaceans that are the base of the food webs in the Southern Ocean, for example, estimating that the carbon sequestration potential of krill population is equivalent to all blue carbon ecosystems together. And krill are suffering habitat reduction from climate impacts and also from overfishing. So those are the connections between the problems, but also between the solutions, because in the Sustainable Development Goals that you showed the interconnectedness of the problems, but also the solutions. Through healthy oceans, we can also address many of the other goals.
Well, which will we get to in a second.
Get carried away.
Yeah, no, it's okay. I don't know, Julie, if you want to add anything else.
I mean, I think Theo has covered. I guess I would just say, it's hard to pick what's the most urgent thing. Absolutely, the changes happening because of greenhouse gas emissions, is the biggest thing, the most terrifying thing. I mean, we've all been reading about it, and if you're a scientist and probably read all the papers that Theo reads, you would be even more terrified. But I would lay onto that, though, that's why some of these interventions that we can do to help the ocean be resilient and recover, and or at least weather the storm, like setting up protected areas, like laying off the overfishing, all of those things. Those are kind of near-term, interventions that we need to do now, and we can do those things now because, of course, we need action on climate change. But it's a big curve to big curve to level out, a big ship to change course on. So yeah.
Julie, Bert, I know before we go into directly the solutions, I would like to ask you, there are so many solutions out there, right? But what do you think are some of the unintended consequences of the existing solutions that are out there? And, how can we be careful before, implementing those solutions?
So this really speaks to the need for research. So one example, Theo mentioned the warming ocean temperatures that we've been seeing with the records put up in the NOAA maps. And though not all of the causes are completely understood, one of those is the reduction in air pollution that has been happening with the North America and Europe, all trying to reduce their particulate matter, which is a great outcome for our air quality. But as a result, we're creating less cloud seeding that is then reflecting less sunlight out, which is then causing the oceans in the northern part of the earth to warm. And so though it seemed like a great idea, it has these different consequences. So really focusing on understanding what we're doing and doing the research is super important, because everything is so connected with the ocean as a large ecosystem. And so one intervention we may have unintended consequences.
And I think right now it's important to talk about, and I'm sure everybody here knows that the past month, the East Coast, specifically Florida, has been hit by two back-to-back hurricanes, Hurricane Helene and Hurricane Milton. And that has, devastated part of Florida's coastline. And so I would like to kind of ask, the three of you, I think it's important to understand the importance of ecosystems like coral reefs and mangroves, seagrasses, to help protect these coastlines, right? And so how can protecting these ecosystems help mitigate some of the the effects and the impacts of hurricanes, for example, that are constantly, they're happening more and more often, they're getting more and more powerful. And what are some of those strategies? So maybe, Julie, if we could start with you.
Well, certainly, if we knew if we knew what weather was ahead, coupled with sea level rise, we would not have developed the coasts of the planet in the way that we have. So we're kind of in a fix, to back up on that. Obviously, a tremendous amount of armoring is going to happen. It's already happening. It's very expensive. Yeah, rich countries, are going to probably be able to do something about it, and others not so much. I guess I try to focus on, I have a bit of a more hopeful story that comes to my mind about it, which is where in developing countries where the coasts are being developed, for example, for aquaculture farms, I mean, the loss of mangrove forests, I don't know, maybe one of you has the number, the percentage on that, but there's been a massive, massive loss of mangrove forests in all of the tropical regions that have mangroves. They are a huge help in being a barrier to slow down storm, certainly wave action, and things like, having the sustainable standards for aquaculture, which includes things like getting countries to commit to no new mangrove conversion for aquaculture farms. That's something actually we're working on on the coast of India, Seafood Watches. Those kind of steps can really make a difference. And which just means, move back from the coast. And also the thing about these aquaculture farms, I think it's hard to, I don't know that much about it, but it's hard to remediate them after they've been totally polluted and become, the soil's really saline, or it's polluted with extra nutrient pollution. It's hard to recover. But there is a lot of mangrove restoration going on, that being said. And so that's more the more hopeful spin on it. We've got to try to renature our coastlines wherever we can.
Yeah, maybe I will add with I think it's important to realize the actual amount by which living shorelines and coral reefs provide the service of coastal protection. For example, for coral reefs, with the team of collaborators, we put together 27 studies that have measured wave attenuation on coral reefs around the world. And the average attenuation was a staggering 97%. Almost all incoming energy during extreme storms are buffered by the reefs. Similar for mangroves, is a similar amount. So these barriers are very, very effective. Protection and restoration is also fairly cost effective, but there are lots of challenges. In some cases, these habitats are lost, the conditions no longer allow recovery, the technologies, community involvement, local knowledge is also very important, the siting of restoration sites, all of the investments in protecting what's left and bringing back these habitats. In terms of restoration technology, fortunately, for mangroves, for seagrass, for corals, it's fairly well developed. It's one of the solutions where the knowledge is there. It's a matter of understanding what the full sort of portfolio of stressors and challenges and trade-offs are, but no, there are ways. So these habitats do provide an incredible service in terms of protection, and then coming from a country which coastlines are very, very intensely, armored, and seeing the tremendous impacts in terms of flooding and erosion, etc. It's just a reminder that there are many other options than combining this sort of green and gray infrastructure to protect it. I think we need both.
Yeah, it's a lot of collaboration. It's a lot of, yeah, exactly. It's not just one single solution.
Yes, very
yeah.
complex result. So
Yeah, exactly.
Well, we're not getting to the kind of call for actions yet, but I think that the science is pretty clear that this is what's needed. So this is now becoming a policy question. And it's becoming a question of people having the political will to move away from the coast, to decide that we're not going to develop in those very valuable spaces, to maybe not insure buildings that are built in more vulnerable areas. So in thinking about, the impact, I think the science is pretty clear, and now it's really about a policy and getting people to have their elected officials actually make the changes that are needed to protect the coastlines.
Yeah, exactly. Thank you. Thank you for that. I was gonna I mean, this could go into the question about, the importance of marine protected areas as part of, as a policy to kind of like protect these ecosystems, right? But I would like to move just a little bit right now to the technology and innovation part of the conversation, right? And I would like to start with you, Julie, and kind of like, can you, talk a little bit about, how can technology help us understand and monitor, what's been happening in the ocean, related to climate change and the issues that we've been discussing. But also, I would like to bring the role of artificial intelligence and maybe in advancing some of these, conservation efforts. So could you talk a little bit about that?
Yeah, sure. So as Julie laid the groundwork for, I mean, the oceans cover a vast amount of our globe, but they're very difficult to measure, in part because the extreme environment needing to weatherize your sensors, needing to develop them such that they don't biofoul and all these different things, and also to measure very large spaces. So there's a whole spectrum of sensing solutions that come into play here. The first ones are satellites. So monitoring from satellites allows you to measure, to look at kind of large areas of the ocean, but you're looking at a fairly long length scales. And you don't have persistent temporal resolution on your data. So the satellite will pass over a certain region of the ocean once every few days or things like that. So you want to supplement those very long, large scale, long time period measurements with more localized measurements. And so a lot of the work that MBARI is doing, for example, they make very exquisite instruments that can measure very locally and get you that information. But then you still are challenged because you're at the two very broad ends of that spectrum. And so then there's another set of sensors that can play a role with the NOAA buoys that are tethered out there. You can put kind of, I think it's about 1,000 of those throughout the world, but still those are relatively local point sources. So one of the things that we've been working on here at SRI has been developing really low cost ocean drifters as well. So these you can deploy thousands of them for the cost that you might have for one of these more exquisite sensors. And they can measure on much smaller length scales and get you that much finer temporal data. And that can allow you to bridge all of these different sensing modalities. So you can try to figure out the interstitial area between what the satellite is showing you, what the local surface sensors are showing you, and then what the more exquisite underwater sensors are showing you. And this is really where AI can play a role here, because the models, as we've developed them over time, have been designed for the sensors as we've had them in the past. And so as new sensing modalities come online, it's not always clear how you adapt those models. And so with AI, you can kind of train to get that integration between a larger scale sensor and the smaller scales, and also to integrate other sensing modalities as well. So when normally you think about temperature, you may think about wave action, you may think about salinity, but there may be other additional modes like acoustic noise that you could start to integrate in. Some of those other types of sensing modalities that aren't typically in our models, AI can also be used to integrate them to gain a better overall understanding.
And like how, I mean, for, just for reference for our audience, like, could you like describe them a little bit? Like how these like sensors look like? How many would you need to really...
So the drifters that I work on, they're about the size of a volleyball. We've built 5,000 of them in our government-funded program. Did 2 large deployments, 1,800 of them in the Gulf of Mexico and another 1,800 in the North Atlantic. And what's really interesting is they'll follow the surface currents. So you can go out on a cruise for one day and put them all out in a particular region, and the currents will distribute them over vast regions. So though they were in the North Atlantic, for example, though we distributed them off the coast of Delaware in just one afternoon, over the course of the next 18 months, they went as far as Northern Ireland and towards the Azores and to Spain, and you could actually watch the whole Gulf Stream be imaged basically by their locations, as well as then also getting more localized measurements of the sea surface temperature that we could then correlate with the satellites and get that data throughout.
Oh, it's amazing. Thank you. Julie, I want to bring now the Monterey Bay Aquarium Research Institute into the conversation. You start talk a little bit about, what MBARI does, and the ocean, for a lot of people is, an out of sight, out of mind kind of place, right? We know, we keep hearing that we know more about the surface of the moon and the surface of Mars than we know more, about our own ocean. So what could you, and you talked a little bit about that in your keynote, some of the technology that MBARI is using, but could you highlight some of those technologies that that are being used to monitor and research these deeper ecosystems, and talk about them?
Yeah, absolutely. Well, first, picking up on what Julie was saying, super cool work. And this matter of having instruments of instrumenting the ocean, which is just an important thing. I guess I always think about it in the context of how well we've instrumented the atmosphere. You can go online and find out weather conditions and weather predictions. And it's obviously, we're humans, we live on land. We need a weather report. There are airplanes flying around. There's the military. There's a lot of reasons why. And one of the big projects that MBARI has been engaged with, although it's a global project, is this Global Ocean Observing System, which are big buoys that have more instruments on them, similar idea to what Julie was talking about. And especially in the Southern Ocean, where there's a lot of change going on around around climate change, changes in the ocean, and we don't have good measurements there. If you look at a picture of the globe and look at all the dots where the buoys are, they're all over the place. And then you get down to the Southern Ocean, I know they're like 3. Anyway, that's an exaggeration, but one of the really cool projects MBARI is involved with now that has an acronym, Southern Ocean, I don't even know what, but anyway, international collaboration, is going to put these profiling floats down there. And they actually go down, they drift, but they go down and sample down in the water column, and then they come back up. One of the instruments that I think the MBARI team is most proud of inventing is this thing called it's called Environmental Sample Processor, which is like a really boring name that could mean anything, right? It is a process. It's a device that takes a seawater sample, essentially measures environmental DNA, does PCR reaction out there in the ocean on this float, and will tell you if there's harmful algal bloom species there, or a dinoflagellate bloom, or pretty much whatever you would want to program it essentially to be able to look for. And that is really a pretty revolutionary thing. We hear a lot about environmental DNA. The idea being that, little bits of DNA from, the shreds of like fish skins or all the life, there's all these bits floating around in the ocean left behind by the living things, and you can tell what was there. And one of the fun stories about the development of that device is they needed a controlled environment to see if it worked. And so they said, hey, the aquarium, they've got tanks. with known fish species in those tanks. And so they tested it out in one of our big exhibits. Well, what they found out was there's some species in there that like they weren't on exhibit. Like, what are these? Where did they come from? It turned out it was some of the seafood that we were feeding was not as advertised, which was pretty interesting. But anyway, it worked great. But that was a sidebar. Fun collaboration between the two institutions. Well, so I guess just quickly, the interesting thing about MBARI is that it's deep water very close to shore. And when you see, the cool video from Alvin and all of the deep sea vents, all of that work, they have to spend like days motoring offshore, and then they have a few days out there to do their work. MBARI can get out to, 5,000 or 10,000 feet deep within, a matter of hours, very close by. So they can do repeated visits to the same spot, and they can leave instruments on the seafloor, and they can go back to the same spot. You may have seen the mother octopus that brooded her eggs for 4 years, which is the longest known brooding time of any animal so far, I think. And that was only possible because they go back to the same spot. Many, many things that they are able to monitor, and those are just a couple of the instruments. They're more acoustic, using acoustics, looking at the soundscape. Actually, you can go on MBARI's website and listen to their acoustic monitor in Monterey Bay and hear all the whales and dolphins out there chatting all the time. And but that's helpful in terms of, for example, we had that deployed down monitoring some sites for proposed offshore wind development in California, just to get a baseline of what the conditions are that could be impacted by the very major acoustic signal from the wind farms, which I'm all for wind farms. We're just trying to get the science, make sure that we get the adequate science under our belts to, to do it properly and have minimal impact.
Great, thank you. And Julie, you started talking about environmental DNA, and I wanted to ask Fio a little bit more about it, because we've been hearing a lot about like the importance of eDNA in marine conservation and how, it's an interesting and important tool when it comes to studying, animals that, just passed by, were there many years ago, in a very minimally invasive methods. Also study, marine species that are no longer there. So I was wondering, Fio, if you could just talk a little bit more about like how eDNA is being used for marine conservation, and is there anything else that really excites you about this technology or any other technology in your field?
Yes, thank you. Going back to the challenges that we started this conversation with, one of the challenges is to track change in oceans because of their vastness, because of the unknown, how little we know, the diversity, the spaces, the cost and logistics. So our information about biodiversity has been increasing very slowly. Environmental DNA has this revolutionary potential to create an enormous amount of information on biodiversity in locations also that are remote and hard to access, where traditional sampling methods might be hard to implement. So as organisms go through the water, essentially they shed mucus, skin, waste, they leave a footprint of their presence that can last hours to days sometimes, and then essentially go out, you take 1 liter sample of water, filter process, do all the things that Julie described, and there's species list, that is information about species that with traditional methods you never see because you're there for a very small amount of time and now become a snapshot. So the potential is enormous. There are still many, many steps before it can be scaled. It already is providing incredibly important information on endangered species distribution. There's applications to fisheries, for example, and understanding bycatch by sampling the waters in boats, all sorts of implementation. A recent one focuses on large marine protected areas. We were just starting to talk about marine protected areas, large sanctuaries, areas like the Monterey Bay National Marine Sanctuary, Chumash Heritage National Marine Sanctuary was just implemented, and also in experience with the sanctuary that was implemented by the Republic of Palau, this vast area that is the size of California. In that example is especially compelling because this is a large marine area that has very limited information on the diversity and also relatively limited local capacity to conduct the offshore work that requires autonomous vehicles and vessels, etc. So in Palau, in collaboration with the government of Palau and Palau International Coral Reef Center, the local research institution, we have applied ENA, or at least explored the potential of the DNA for establishing a baseline of biodiversity in the sanctuary and tracking change as this area that is so important and there's been such an investment in protecting is affected by climate change and fisheries. But that is the potential is enormous for scaling, and it has transformed our ability to explore biodiversity, not only in the surface, but at depths on seamounts and other important habitats. The developments that are needed are very much in the collection, processing, interpretation of the data, like the environmental sampler. So another example that I can briefly mention is ongoing work that leverages nanophotonics and applications of nanophotonic sensor chips in other areas, in medical fields, for example, for environmental DNA. And collaborators in the Doerr School of Sustainability have developed a first prototype of these chips that are less than an inch across and have hundreds of thousands nanoscale sensors that bind with target molecules, for example, an endangered species of interest or pathogens or other molecules. And essentially, that binding changes the color of the light that is emitted, that is then captured and analyzed to then link the patterns to the presence of certain species. So with further development of these and other technologies can revolutionize not only our understanding of biodiversity, but the scale where this work can be conducted, and also the access to communities and nations and regions that perhaps have fewer resources and infrastructure for marine science.
Yeah, which is just a quick reminder, if you have any other questions that you want to pass along, just going to ask like one or two more questions and we can go to Q&A. I want to bring the question about environmental justice into the conversation because I think, and you started talking about this when it comes to collaboration with governments, with communities, and Julie also talked about this. Julie talked about this in terms of policy. Environmental justice is deeply connected to, ocean conservation, and low-income communities and communities of color tend to, bear the brunt of the impacts of climate change, right? But what we often don't think about is like how these communities can and should be leading the solution and should have a seat at the table. And you started, Fia, talking about some of those community-based solutions, but I was wondering if, Julie, if you can talk a little bit more about some of those community-based solutions and what they look like to make sure that those conservation efforts are inclusive and equitable.
Yeah, absolutely. I mean, starting here in California, which again, we are a very rich state and we should be able to figure all of these problems out. But as we know, we're also leaving a lot of people behind in our state on many levels in terms of being able to benefit from the bounty here. And one of the things that we've been doing at the aquarium really is supporting small community-based advocacy organizations throughout the state, which these are needed throughout the nation, honestly, whether you're talking about the coast of Louisiana, where there's incredible flooding happening, or all of these places. And here in California, though, we have really amazing voices that are being raised, and with more and more legislators that are, especially the Latino population of legislators in California, these voices are really being heard, which is great because it'll bring more resources and more attention to the places where impacts are really felt. And certainly the extreme heat in all of our agricultural areas is a huge problem. We also have a lot of low-income areas that are parts of the state even below sea level, like El Viso, for example, which is really a forgotten part of our state. That's right here. Further afield, it's really about engaging, or not engaging is not the right word because that sounds like us trying to engage them. We need to shift our mindset to sharing the information and the tools that we have, in countries like ours, and enabling local communities to create solutions. And for example, when it comes to managing fisheries, traditionally, all the fisheries in the Western Pacific nations were, locally managed by agreements among communities. And that's a great solution, locally managed areas for marine protected areas for a lot of regions. The problem is industrial nations have come in and, are taking all the fish away because the fish have become a commodity. So in that sense, just local control, local solutions is really moving things forward. And there are some really great, great examples of that where that's happening.
And I think I want to ask one more question, for all three of you to kind of like finish our panel before we start our Q&A. And we are constantly hearing, this climate apocalypse narrative, right? And doesn't mean that we don't need to hear that information because it's important. It's really important. But what we often don't hear is what does it look like if we get it right? So maybe, briefly, I would like to ask each of you, what does that future look like if we actually get it right from your perspective, from your field? So Julie, I would want to start with you.
Sure. I mean, I think it's really about inspiring the next generation to want to be interested in this and to want to do the research and to take forward the solutions and continue to carry the torch for having impact as we move forward. So it's really about, making sure that our kids are excited, our students are excited, and because they'll be the force of change for the things that, we may find difficult now.
Yes, I think that interconnectedness, the fact that a vision for the future has healthy oceans, has equitable access to important ocean resources, have food security, those, the prosperity and nature together, people and nature, is the vision and the motivation to be optimistic that investments have all of these benefits. Another important point, I think, that you both touched on in our discussion is the success stories. The need to elevate the successes, not only because they're inspiring, but because we learn from them. Those positive cases teach a great deal about what can work together with failures. We learn a lot for failures, but those successes are really, really important lessons. And then I think that sense of awe, the inspiration that comes from seeing these amazing images of coral spawning and the seamount. I think that ultimately that connection is what might engage and inspire the public. So because we know so little about the ocean, the silver lining is that anywhere you go, you find incredible things. Hydrothermal vents were first discovered in 1977, at the time where all these historical developments were happening there. We did not know that those ecosystems existed. We did not know that primary production could take place in the absence of light. through chemical reactions supported by microbial communities, a whole new way of biology, non-biological interaction. So that potential for discovery, that we need to convey that excitement and the fact that it's, that's the frontier, that's where we will find the solutions, I think.
Thank you for that. And Julie?
Well, Julie and Fio, you covered a lot of territory there. Just that, all that. What was coming to my mind, and I guess I'm just kind of piling on, it's not just because those were great remarks, really comes to the importance of motivating people, the public will. That's the biggest thing that's missing. We have the climate change solutions. I mean, not all of them, certainly some of the some of the sequestration solutions are a big R&D project, assuming some of those will be necessary to engage, but the public will is what's needed. And with that, of course, I get thinking about young people. And I think we all read every day, we have a huge mental health crisis going on in our nation with young people, especially teenagers. And and we also have I forget what's climate depression, climate anxiety. That's a real thing, and this is a huge problem. So what we're trying to do at the aquarium, and what I think all of us can have a role in, is, as has been said, expressing optimism, but also for all the young people around us, showing them care and empathy and support so they can have the mental energy to, have some optimism and wrap their mind around, yes, there are solutions and we can, we can turn this around. And yes, I am going to engage and vote. And yes, I am going to engage in finishing school and hopefully going to college and being part of a positive future for myself and hopefully my family in the future as well.
Thank you. Thank you, Julie. Thank you, Fio. Thank you, Julie. Mike, if you want to read some of the questions.
Sure. So we have a lot of great questions. We're not going to have time for all of them. I will try to summarize 3 of them that are very different, but all on the related theme of technological innovation. So one is related to leveraging the critical resources in the ocean, such as seaweed and seagrass, as a potential alternative to plastic. Second is, what is a good strategy to use ocean as a carbon sink while keeping ocean acidification in check? And the third is a much broader question that really has to do with resilience and protecting our cities. It's phrased very simply: can we save Miami and New Orleans?
Who would want to start answering the question?
And I'll do the easy one, which is the seaweed and seagrasses.
That's a natural.
A natural. There is a lot of interesting work, a lot of startups, a lot of R&D going on to develop more benign alternatives to plastic. A lot of them, I mean, there's hundreds of them around. I'm not personally familiar with ones that are being developed from seagrasses or kelp, but the whole material science aspect, and it not only goes for when we think about plastic, of course, we're thinking about usually what comes to mind is plastic debris, plastic bottles, we need to get rid of those disposable single-use plastic. Textiles and all of the petroleum-based things that we wear every day are another huge opportunity for innovation. And yes, I for sure, I would imagine that seaweed and seagrasses could produce some of the raw material. I will say, you don't want to be harvesting all the kelp on the seagrasses to produce these products, because the seagrasses and kelp beds are all imperiled themselves, A, and B, they're not, you read about, oh, we can sequester a lot of carbon with mass quantities of seaweed farms and new seagrass beds. that's a big long shot. I mean, it is not easy to grow seaweeds at that kind of scale, I will say. And as far as seagrasses go, I mean, animals need these habitats too, and they provide protection for human society on the coast. So in any case, yeah, interesting idea. I wouldn't expect to see anything on the shelves anytime soon, and I would urge a bit of caution.
On the topic of using the ocean as a carbon sink, there's a lot of interest right now in the DOE and the government in looking into some of these programs. But again, cautioning to really understand the impacts that we're having before we go in whole hog at something like this, because this is a good example of where we've been acidifying the ocean unintentionally for a long time and just starting to really understand the impacts that are happening there. And so doing more focused, more local, smaller scale experimentation is really what's necessary. So I don't know the answer as to whether or not that can work. It's certainly something that we should look into, because by not researching it, you leave those possibilities on the table, but it's something that should be looked at in controlled, smaller scale ways before we embark on anything large. And there is interest right now in the DOE to be doing just that.
And if I may, if I can link the two, one really incredible opportunity that we have as scientists to learn about the effects of ocean acidification on entire ecosystems are underwater beds. Sites where there's bubbling of carbon dioxide. They're found in coral reefs in Papua New Guinea. They're found in the Mediterranean. They're found in the Caribbean, for example. And so that you can see what happens to entire ecosystem when they're acidified. And as now we have discussed, there's losses of diversity, loss of function. But one very interesting result is that seagrasses appear to thrive at these sites. And so not only seagrasses, because they can take up the bicarbonate that are the basis for photosynthesis, so they have resources at these sites that they can use, but then also through that they can mitigate some of the effects of ocean acidification. And there is a lot of interest in seagrass conservation, restoration, seaweeds as a way of buffering ocean acidification, at least at local scales, for example, around oyster farms, etc. So there are also these potential, an illustration of how information understanding is absolutely key, because any solution can have unintended consequence, and there are trade-offs. And as we understand those, we can make more informed decision about what is a course of action that offers a solution but doesn't create a worse problem, basically.
So nobody wants to take on Miami and New Orleans? We can go on to the next question. They're also related. What have you learned that is most likely to impact, that we can do that's most likely to impact our understanding of the ocean, societal understanding? And then this could be sort of kind of leading the witness in a sense, but how do we build more nature memories if we believe that's critical to raising a environmentally, socially conscious electorate and group of citizens? How do we create those nature memories?
I mean, I would, for the first question, I would like to answer that. I'm a filmmaker and a journalist, and I think that storytelling is one of the most powerful tools we have to connect people to places, ideas, and information. And because the ocean is, it's a place that is very, very few people get to see and experience. And, from that privilege of being able to document what's happening in the ocean and telling those stories and transmitting those stories to a bigger audience, I think that's really important to share first, like the problems, but also the solutions and how we can all together kind of like work on those solutions.
I would second that. I heard the story of the octopus mom on a podcast actually just a couple weeks ago. So very impactful in that sense. Really excellent storytelling.
I would only add that there are many different ways of telling stories. And I think an opportunity to bring humanities, arts, lots of other ways of telling stories that connect to different parts of our brain, of our experience, of our culture. And so that is another opportunity to create a memory and understanding that belongs to everyone.
I would just add, having led an organization that is all about creating memories, it's amazing how many people living very close to the ocean in our very wealthy state of California have never seen the ocean. So, and honestly, it would be great to have a Monterey Bay Aquarium, every 50 miles throughout the entire United States. However, that is not feasible. So, I mean, the amazing video productions and all of the things that can be disseminated by social media, we got to do it all. And those opportunities are just getting more and more amazing because of our ability to visualize what's down there. I mean, the deep sea video footage that's coming is just mind-boggling. These are totally new animals no one even knew existed. And we don't know anything about many of them yet. That's okay. They can spark the wonder for sure. And yeah, so, and I suppose in all the communities, certainly in the US, that have that are anywhere near the coastline, I guess I would just finally and say I had the opportunity to be on a public commission to make recommendations about California state parks and how to improve them. One of the things we learned was it is appalling how hard it is for low-income families living inland, even a couple of hours inland, to make it to the beach. It's like a 4-hour trip from East LA. So just attending to public transportation in all of our coastal cities is a start.
Do you have any more questions, or?
I've got a ton more questions. I don't know how much time we have.
But I think we have to wrap up
Should we do
right
one
now.
more?
One more?
One last one?
Okay.
So we have in this panel educators, storytellers, and researchers, but a lot of people are none of those things but concerned about the health of the oceans and the health of our climate more generally. What should those people do?
The question is, what should people do who don't know about or care about the ocean?
No, people who do care. No,
Oh, people who do care.
Certainly who do, but perhaps are not themselves storytellers, researchers, educators.
Oh.
Concerned citizens, I'd say.
Sorry, misunderstood. Well, wow. There are so many things. I would start with vote. This wouldn't surprise you. That's where I'd start, but in your local community, in your state, in your nation, wherever you are, because so much of ocean protection is about policy solutions because no one owns it. I mean, governance is required, and share what you learn. Get involved in an organization that can connect you with actions. Obviously, the aquarium's one. There are many others. There are a lot of opportunities to engage in policies that are underway, and then in all of our personal lives, we could all have a lighter footprint when it comes to the ocean. That's for sure. And each of us, driving an electric car is not going to solve global climate change. We need to realize that. But I view it sort of more like a matter of either hypocrisy if I don't do everything I can, and or moral responsibility to do everything I can, and show it's possible, and talk to your friends and family about it, and spread the word, because all of us here in the U.S. and our lifestyles, we are a big contributor to a lot of trouble around the planet when it comes to the environment.
Yeah, I guess like to add, maybe you're not storytellers, but you consume stories. And that's part of, caring about, reading, getting that information and getting that information across to your friends, your neighbors, your community. And I think that's really important. And, you know, maybe there's a story that really sparked that interest, then that's going to, you know, make you go and, you know, watch a video or read something else, and then that's going to take you somewhere else. And so I feel like it's kind of like a, you know, little by little, and, you know, informing yourself is really important, and consuming that information. I don't know if anyone else wants to add anything else, or that's it. Yeah. Okay. Great. So thank you everybody for being here. Thank you to our great panelists. And I'm going to now hand it over to you, Mike.
Thank you. Thank you again for coming. So our panelists are going to walk through those doors. And I just want to remind you that if you enjoyed this event, tell your friends. We would love to see you again at our next events, sri.com/events. You can find out about more and sign up on our mailing list. You're all welcome to go on ahead. We invite you to join through those back doors, and then up the stairs through which you came in, and there'll be signs that sort of take you around to the reception, where you'll have plenty of opportunities to talk to our panelists. Please take your things, because we will be locking the doors, and we look forward to seeing you all upstairs. Thanks again for coming.